would be taking up section formula of the coordinate geometry. Herein I just simply write on the topic I'm taking. Section formula. Okay, let me understand, or let me discuss what does this basically is referring to it or it means. I draw a small Cartesian plane. Suppose there are these coordinates of 2 points been given, maybe A and this being B. This is given by x1, y1 coordinate, and it is given by, suppose, x2, y2 coordinates. Let me join the points to make it a line. There might be under some circumstances wherein there is a point here which lies on the line AB. Maybe I can name it as P. Maybe I'll name it as P and assume it is given by the coordinates x and y. In what ratio is this P dividing? It's not necessarily every time is the midpoint of AB, though it might be a case where it is the midpoint, but we need to just know in what ratio is this P dividing the 2 points joining and making a line. Now let us understand the figure which I have drawn is referring when P is dividing AB internally. So I'll just write the case which says P is dividing AB internally. The ratio, suppose, is given by, in the ratio, maybe I could read it more appropriate way of doing so is, ratio of dividing it, suppose, is given as M1 and M2. Because somehow when we write a ratio, just to explain, I write a ratio always in the terms of like 3:2, or maybe 2:1, or 3:4, whatever way we write it. This ratio is 1, this is referred to as M1, this is referred to as M2. I'll just erase this, we don't need this, I just had done it for explaining, which is M1 and M2. Now I have already told you I'm assuming A to have coordinates x1, y1, B to have coordinates of x2 and y2. So the formula, the section formula which is given says to find the x coordinate of the point P is given by M1 x2 plus M2 x1 by M1 plus M2. This gives us the x coordinate of the point P which is dividing A and B, and the y coordinate is given by M1 y2 plus M2 y1 by M1 plus M2. This is how you calculate the xy coordinate of the point P when it is dividing AB internally. Suppose this point is midpoint of AB. In that case, what happens? That means the ratio, this M and M2 becomes 1:1. So if you replace it here, M1 plus M2, that becomes 2 in both the cases. And you replace a M1 here with a 1, M2 here with a 1 again. So in the numerator, you are left with x1 plus x2. And in the y coordinate, you are left with a y y1, oh sorry, a y1 and a y2 by 2. This is separately referred to as the midpoint formula. Let me just write it down. This is called the midpoint formula. But I told you how is this being derived, because m1 and m2 are 1 and 1 by themselves when p is the midpoint. Now we'll take up the case where it is dividing AB. It means P is dividing AB externally. Let this being A, this being B, and this being P. This I write as A, as we have already taken it as A1, X1, Y1. I'll keep the same here as well. This is B, which we have already given above as X2, Y2. And now this is P, which is dividing AB externally, that is referred to as XY coordinate. Herein the section formula, which will give the x coordinate of this point, which is P, as m1, I just write x equals to m1 x2 minus m2 x1 by m1 minus m2. This gives the x coordinate when P is dividing AB externally, and the y coordinate is given by m1 y2 plus m2 y1 by m1 plus m2. Oh, I'm so sorry, this will be all minus when it is externally dividing. So these are the 3 formula we will be taking up in the next couple of questions. Let us take up a first simple question which can directly apply the section formula. Let me just write down the question here. It says find the coordinates. This is a direct application of the section formula. Find the coordinates of the point which divides the line segment joining the points 4, -2 and -3, 5 internally and externally. So in one question we'll learn how to find out both the internally externally division of any line segment in the ratio which is given as 2:3. So I'll just assume that let P is internally dividing, which I suppose is given by xy coordinate, internally divides this line segment. Maybe I give this as A, B. We have to find this. Let us apply the formula which is internally dividing AB as m1 x2 plus m2 x1 by m1 plus m2. So this gives me, this is my x1 y1. I'm just writing here for our convenience. So this is giving me and this being my m1 and m2. So it is 2 into -3 plus 3 into 4 by 2 plus 3. That's minus 6 plus 12 by 5. It is 6 by 5. So the x coordinate of the point P is 6 by 5. Now I'll apply it on the y coordinate. Sorry, excuse me. m1 y2 plus m2 y1 by m1 plus m2. So this is again 2. My y2 is 5 plus m2 is 3 and my y1 is minus 2 by 2 plus 3. That gives me 10 minus 6 by 5, so it is 4 by 5. So the P coordinates is 6 by 5 and 4 by 5 when it is dividing AB externally. We also have to calculate when it is dividing AB externally. Sorry, this the one we calculated was internally. Now we'll be taking up for externally. So I give another coordinate, maybe x dash y dash, which is dividing AB externally with the same ratio 2 is to the 3. The formula was m1 to find the x coordinate, m1 x2 minus m2 x1 by m1 minus m2. So that I take up m1 was 2, x2 was minus 3 into 4 by 2 minus 3. That's giving me a minus 6 minus 12 by minus 1. So it is minus 6 minus 18, sorry, minus 18 by minus 1. I'll just erase and make it more clear. So minus this minus getting cancelled. I'm getting a 18 as the x coordinate when P is dividing it externally. Let us calculate as well the y coordinate, which was given by m1 y2 by m2 y1 by m1 minus m2. So that gives me 2 into 5 minus 3 into minus 2 by 2 minus 3. So it is 10 plus 6 by minus 1. So it is 16 upon minus 1, which is giving me the coordinate minus 16. Now if I write down the coordinates of the P, which was given by x dash y dash, I get 18 minus 16. So overall I get this being the coordinates when P is dividing the line joining AB, and this being the coordinates when the same P is dividing the line joining AB externally. This is internally, this is externally. So we have solved it rightly. Thank you.